This MCQ is from NEST 2023 Shift 2, question number 12. Consider the Bohr model of the hydrogen atom. Suppose that the charge on the proton were 1.1 e, while the electron charge continued to be negative e, but the masses of both remained unchanged. Then the angular frequency of revolution omega b of the electron would have remained unchanged, would have changed to root 1.1 omega b, would have changed to 1.1 omega b, and would have changed to 1.21 omega b. Okay, so we still have the Bohr model of hydrogen atom. The only thing is the charge on the proton. Okay, let us call it Qp. That is 1.1 times E, and the electron charge continued to be negative. Okay, but the masses of both remained unchanged. Then the angular frequency of revolution omega b of the electron would be. Okay. Now, first of all, you have to understand how we calculate omega, right? This can be obtained by considering the expression for the circular motion, right? Uniform circular motion. What is the expression there? Suppose Rn is the radius, okay, of nth stable state, whatever that is, 2 pi Rn, nth value. And so if this is the circumference, then this will be equal to Vn into t, correct? Vn into t, because t is the time period, so time taken to complete one revolution, that is time period. And what is omega then? Omega b. Omega b would be 2 pi by t, correct? Omega b will be 2 pi by t angular frequency, and then that will be equal to Vn by Rn. Okay, have you understood this? Omega b is equal to Vn by Rn. Okay. Now let us come to the changes that they have given us. Okay. The electron charge continued to be negative E, but proton charge increased to 1.1 E. Now look, here are the two formulae which we derive from the Bohr's postulates Vn and Rn. Okay. Observe that Rn is proportional to 1 upon E squared into me, correct? And Vn is proportional to E squared upon well, there is no mass here, right? So no need to consider that. And anyways, they are saying that masses don't change, masses remain unchanged, which means we have to now make use of the fact that Rn varies inversely with E squared and Vn varies directly with E squared in order to calculate omega b nu. Okay, or let's say just a proportionality relationship, if we can use that. Observe that here this E squared that we have written, this E squared is actually charge on proton into charge on electron, and same thing applies to this E squared also, correct? And where does that E square come from? That E square comes from Coulomb's law, because the other equation mvr is equal to nh upon 2 pi doesn't have charge on electron, so it has to be the Coulomb's law expression, q1 q2 upon r square, correct? So I can now say that omega b nu is directly proportional to, look, this E squared will now get replaced by what? 1.1 E squared. Okay, see, no, That 1.1 e squared, I can write it as 1.1 e into e. Why 1.1 e? Because one of them is qp. Okay, one of them is qp, and that qp is this one. Okay? And in the denominator, what do we have here? We have got Rn. Rn is proportional to what? 1 upon e squared. Which means in the denominator now I need to write. In the denominator I need to write again 1.1 e into e. Correct? And then this goes in the numerator. This goes in the numerator. So we get omega b nu directly proportional to what? 1.21. And well, that will be e raised to 4, but that hardly matters now, right? What is omega b old or omega b original, which is Vn upon Rn? See, I can say that this is proportional to e raised to 4. Everything else is constant. Vn by Rn if we take the ratio. Okay, so what does that give me? That gives me omega b nu equal to 1.21 times omega b old. So which option is correct? D is correct. If you have not understood it, please note that to solve the problem we have to first identify the relevant variables here. Okay, you need to know the formula for Rn and Vn, there is no way out. And of course the formula for omega that we use in uniform circular motion. Once we get it, then identify the things that they are changing. Usually we let Rn to be a function of n, in some cases z, right? Z is the number of protons. That might also be different, but in this case they are saying assume a hypothetical situation where E changes, mass of proton changes, mass of electron, well, they have not changed, but they could have also changed that, and then we derive the relationship between omega nu and omega old.